Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve the same problem which we solved in previous lecture, but using the another method called transformed section method. So this is the problem over here. We already read this problem in previous lecture. So let us solve directly. So this is the material 1 and this is material 1 and this is material 2, right? So in transformed section method, we are going to transform one of the material's cross-sectional area. So let us take the more value of E2. So modulus ratio and modular ratio will be equals to E2 by E1. That will be equals to given 210 by 10.5. Okay, this will be 20. So this is B. So for material 2, that B will become NB. So NB will be equals to 20 into 100 mm. So that will become 2000 mm. That means 2 meters. Okay. So the transformed section will look like. So this is 100. Transformed section will be this as 2000 mm. Okay. And this height is same. This is 12. This is 12 only, but I drawn it. And this is 150. Figure is not to scale. Okay. So in transformed section method, now for what will be the neutral axis? Neutral axis will be centroid transformed section, right? So suppose neutral axis is present over here. See, for this part, for this material 1 part, the centroid will be over here. So this distance will be 75 mm, right? And for this part, the centroid will be over here. And this distance will be 6 mm. This will be 6 mm. And the overall centroid will be somewhere here. We need to find out that value. So we taken this as H1 and this as H2. Okay. So if you take one reference, suppose this is the reference line, we can write sigma yi divided by sigma ai. Okay. So from the reference line, the distance to the neutral axis is H1. So this will be equals to H1, right? So H1 will be equals to y1 into a1. y1 into a1. What is y1? y1 is 75 mm from the reference line. So 75 into a of material 1 is 150 into 100, right? Plus for this one it is 1, this is 150 and this is 6. So that is 156 mm and area A is 12 into 2000. Okay. Divided by a1 plus a2, that is 15,000 plus that is 24,000. So from this we can calculate H1, that will come as 124.8 mm. See, in previous method for calculating H1, we did tedious calculations. We did many steps, but here it is going in very easy, right? It is going little bit easier compared to previous method. So we got H1. From that we can write H2 is equals to 150 plus 12, 162 minus this H1, right? So that will be is equals to 37.2 mm, right? So this is H2. We got H1 and H2. Now in transformer section, we need to calculate only one moment of inertia, that is IT, means moment of area, moment of inertia of transformer section about neutral axis. So here also the calculations will be somewhat easier compared to previous one, where we need to calculate I1 and I2 and we need to calculate E1 I1 plus E2 I2. So here that is not a problem. IT will be is equals to See, moment of inertia of this one about center of mass will be 1 by 12 into breadth is 100 into height h is 150, right, for that whole cube. This is about center of mass plus area is 150 into 100 to the distance from the center of mass is this 75 h1 minus 75. So h1 is 124.8 minus 75 whole square plus moment of inertia due to second part. Okay, that will be 1 by 12 again into the breadth is 2000 here and the height h will be this one. Sorry, this one. Mm, this is 12. So that will be 12 whole cube plus this is about center of mass. We need to shift to the neutral axis. So into area 12 into 2000 into the height will be the distance will be from the center of mass. We need to measure from center of mass. So this is 6 and this is, so we can write this as h2 minus 6, right? So that will be 37.2 minus 6 whole square. See, again the calculation of area moment of inertia is easier in this case. So you will get as 89 into 10 power 6 mm power 4. Okay, relatively much easier compared to previous method. So now simply we can write, we need to calculate sigma 1 in material 1 maximum compressive stress that will happen at point A. So that will be given by, because we didn't change the material 1, we changed material 2 material 1. So here we can, it can be directly given by my by I minus transform section. We know the m and y is given as, y is from the neutral axis to this distance. So this is h1. So the h1 is, this is h1. So minus m h1 divided by it. Again, easier calculations. So you'll get the same answer as previous method. So now sigma 1 max tension that will occur at contact plane C. So that will be minus my by it. So here the y will be, the y will be this distance. So this distance is h2 minus 12, right? So that will be h2 minus 12. So we get minus m into h2 minus 12. That will be negative, right? So we'll get positive divided by it. Okay. So this is again easier as compared to previous method. Now sigma 2 max tension that will occur at bottom plane, that will be my by it, and that y is h2. So that will be m h2 divided by it. Okay. Don't bother about the sign conventions. You know where it can be tension, where it is positive from intuition. See, it is positive bending, so positive curvature. So नीचे में न्यूट्रल एक्सिस की नीचे में टेंशन, न्यूट्रल एक्सिस की ऊपर में compression. From that you can put the signs. Okay. Don't bother about the signs in the formula. So you know the h2, you know the m, you can calculate the value. And sigma 2 minimum tension will be is equals to m into by it y. So this y will be, this y will be, that will be at contact plane, right? So this one, that will be h2 h2 minus 12, h2 minus 12. Did we made mistake in any step? Yes, because see, in material 2 we need to multiply with modular ratio, don't forget that. So multiply with modular ratio, man. Okay, here modular ratio. So see, we already calculated this value, m h2 minus 12 divided by it here. So we just need to multiply with 20. We already calculate, we didn't calculate mh2 by I2. Here we need to calculate and we need to multiply it with 20. So if you see, this method is relatively much simpler as compared to the previous method. So I suggest you to use this method to solve problems in examinations. So I hope you understood clearly both method 1 and method 2, but do follow transformed section method, or this method. Okay. So with this, we end today's lecture. If you like this lecture, do subscribe to our channel 9pointer and do comment in which topic you want further videos. Okay, thank you.